I'm going to share my screen. I hope this is visible, right? Can you hear me?
Yes.
Okay, fine. So today we will talk about nuclear and particle physics assignment 9, week 9. Okay, so I think I should wait for 2 more minutes to people come, or otherwise I should start. Okay, let me start right now also. So this is the week 9, assignment 9, previous year question paper we will going to discuss. So just start. Yeah. So this is the question number 1. First question. The first question is what? The first question says that given that E vector is minus grad phi minus delta del t, A prime is A plus grad delta, phi prime is phi minus del lambda del t. Which of the following is or are correct? Here lambda is a scalar function. So this is the question. And there are 4 options for that. Like E is like minus grad phi prime minus del A prime del t plus 2 grad del lambda del t. This is the A. And then B is minus grad phi prime minus del A prime del t. And C is minus grad phi prime minus del A prime del t minus 2 grad del lambda del t. And the D option is 2 into grad del lambda del t. So what it is given here in that question, they are asking that like what will be the expression for E in terms of prime. Like you can see that this is A prime and this is phi prime. So in terms of A prime and phi prime, what will be the expression for electric field? That is the question. And what they have given here, they have given in unprimed equation. They have given as unprimed equation, and I have to tell that which one will be the expression for primed equation. Now let us start from first one. So here, okay, so first of all we are going to write minus grad phi minus del A del t. Now A prime is what? A prime is A plus grad lambda. So obviously I can tell write A equals to A prime minus grad lambda, right? You can obviously tell that one. And again phi prime is phi minus del lambda del t. You can see it is written here. Yes. So obviously from that expression we can write phi equals to phi plus del lambda del t. So we have the expression for A, which in terms of A prime, phi in terms of phi prime, right? Now what we will do, we will just put that one in that expression del phi minus del A, grad phi minus del t. So let us calculate grad phi. Phi is phi prime plus del lambda del t. It is given here, right? So grad phi. Grad phi will be what? Grad phi will be grad phi prime plus grad of del lambda del t. So I am just writing here again this one plus grad del lambda del t. This is the expression for grad lambda. Now coming to A prime. A was A prime minus grad delta, because you can see here I have written here A prime minus grad delta. So if I write here del A del t, then what will be the form? Del A prime del t minus grad of del lambda del t. And you know that like grad and del are interchangeable, so that's why I can write it like grad of del lambda del t. So we have the expression for del lambda del A del t also. Now coming to E again. E was what? Minus del phi minus del A del t. So minus grad phi is what? Minus grad phi is minus grad phi prime minus this one. So minus grad phi prime minus of this. Now del A del t. Del A del t is what? Del A del t, del A del t, del A del prime minus this one. Okay. So del A prime del t minus grad of del lambda del t. So if I just do a little bit mathematics, then it will be minus del a prime del t plus, because this one is minus, this one is also minus, so it will come as plus del lambda del t. So you can see that this one and this one will cancel out. Then what will happen, it will be like, it is nothing but e prime. If you remember clearly, like in the last week also we have a question that e will be e prime in which condition, and there were 4 combinations of a prime and phi prime. So what will be the correct one? A prime will be a plus grad lambda, phi prime will be phi minus del lambda del t. Or if I just write like that also, a prime is a minus grad lambda and phi prime is phi plus del lambda, then you can check by yourself, that is also giving the same result, that e is e prime. Okay, so now for this question, what is the expression of e? E will be like minus grad phi prime minus del a prime del t. So this is the expression we are coming out. So from that, which one is the correct one? Yes, this one. You can say B option is the correct one. So if you don't have any question, then you can go to the second question. You can see this one, that a prime is this one, phi prime is this one. If also I can write a prime is like a minus grad lambda and phi prime is phi plus del lambda del t, then also it is coming out as e equals to e prime. That you can check by yourself. Actually in previous class also we discussed that one. So I mean, if you follow the previous class also, then you can see that if it is like this or this option or this option, then also we can get e equals to e prime, and e prime is nothing but minus del prime minus del a prime del t. So this is the case. Okay, so the correct answer is B. Now coming to the second question. Yeah, this is the second question. The vector potential A mu representing an electromagnetic field satisfies the condition del mu equals to 0. If a gauge transformation A mu goes to A mu prime as A mu minus del mu lambda leaves the electromagnetic fields invariant as well as retain the condition del mu A mu prime equals to 0, then lambda is what? Lambda is any differentiable scalar function that satisfies the condition del mu lambda equals to 0. Any differentiable scalar function that satisfies the condition del mu lambda equals to 0. There is no scalar function that is suitable here. Any differentiable scalar function. So there are 4 options. So what is the question here? The question is like the vector potential is A mu. It is representing an electromagnetic field, satisfies the condition. This A mu satisfies the condition del mu A mu equals to 0. Okay. If the gauge transformation, let's say our A mu is going as A mu prime, and what is A mu prime? A mu prime is A mu minus del mu lambda. Leaves the electromagnetic fields invariant as well as retain the condition this one equals to 0. That means previously del mu A mu was 0. Now we have transformed our A mu electromagnetic field by gauge transformation A mu prime equals to A mu minus del mu lambda. But they are telling that even if we are changing A mu to A mu prime, the condition del mu A mu equals to 0, similarly it should be del mu A mu prime equals to 0. Then what is the nature of lambda? What will be the nature of lambda? Is it any differential scalar function that satisfies the condition this one? Or is it an artificial equation that satisfies this condition? Or there is no scalar function that is suitable here? Or any differential scalar function? So there are 4 options. So we have to choose which one is the correct answer to get this type of expression. First of all, it is given here this expression in our question, and we have to prove this expression in our question so that we can have an idea that what will be the nature of lambda. That is the main thing. Okay. So now it is given that del mu A mu equals to 0. It is given, right? Now they told that our a mu will go as a mu prime, which is a mu minus del mu lambda. Yes. So, and also they are telling that our lambda should be like that, a mu del mu prime will be 0. So what we will do? We will do at the very first this one. We will calculate this one. How to calculate a mu prime? Now see, a mu prime is what? A mu minus del mu lambda. Now I am just going to calculate del mu a mu minus del mu lambda. Now you can see from that question it was showing that del mu a mu prime should be 0. Then if I just put this expression in our calculation, then del mu a mu, you can see here the expression del mu a mu minus del mu, right? Minus del mu lambda. This should be equal to 0 because this is nothing but del mu a mu prime. And from the very previous expression they have already mentioned that del mu a mu is 0. So if it is 0, then obviously from that expression we can say del mu lambda should be 0, right? I think it is understandable because the left hand side, in that left hand side this one is 0, it is given, as well as this one is also given as 0. So have to have the mathematics correct, del mu lambda should be 0. Now coming to the options, whatever they have given here, you can see in that option, the first of all the option was, just a minute, I am just going to remove these things. So first of all the option was any differentiable scalar function that satisfies the condition del mu lambda equals to 0. It is not correct because we get the answer that del mu lambda should be 0. It is not that del mu lambda should be 0. So this one is the wrong one. Any differential scalar function that satisfies the condition del mu lambda equals to 0. Now see, whatever we have written here, we get the same one as equation option number B. So option number B1 will be the correct one. Now coming to C, there is no scalar function that is suitable here. Obviously it is not correct because we got an condition that del mu lambda should be 0. That type of condition, if lambda satisfies, then lambda can be a scalar function which retains del mu a mu prime will equals to 0 condition. So it is not correct. Any differentiable scalar function, that is also not correct because there should be some condition, and this is the condition. Okay, so this is the whole case. Okay, so I think you understand the question and answer as well. So we are going to move to the next one. Okay, so what is the okay. So what is the correct answer for this question? The correct answer for this question will be B, as we told. Del mu lambda equals to 0. Okay, so now we are moving to the next question. Okay. So given the field tensor F mu equals to del mu mu minus del mu mu, which of the following are invariant under the case transformation? This one, where lambda is a scalar function. There is a typo, it will be lambda is a scalar function. So under the four options are F mu nu, 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 and then del mu mu. So now this is the field tensor and this is the gauge transformation. So which one will be invariant under gauge transformation? That means, let's say I am talking about A. F is what? A mu nu. So F mu nu is obviously this one, but what will be if I write like that? If it is F mu nu again, then we can say that f mu nu is invariant under gauge transformation if this condition satisfied. Similarly, for this one also, if this condition satisfied, then we can say mu nu. So if this condition satisfied, then we can say that this term is gauge invariant under gauge transformation. Okay. So now one by one I am just going to calculate f mu nu. So what we need to check? We need to check is it like that or not. So how to write that? How to calculate? So f mu nu. F mu nu is what? Del mu a mu minus del mu a mu. It is given here, right? Yes, del mu a mu minus del mu a mu. And what is a mu prime? A mu plus del mu lambda. So a mu prime is a mu plus del mu lambda. Now what we will do? We will first calculate f mu nu prime. What is f mu nu prime? Del mu a mu prime minus del mu a mu prime. Now we are just simply going to put the values of a mu prime. A mu is what? A mu plus, you can see here it is a mu, and nu are dummy indices, so we can interchange these things. So a mu plus del mu lambda minus del mu a mu plus del mu lambda. Okay. So this is the case. Now by doing a little bit mathematics here, you can see del mu a mu plus del mu lambda minus del mu a mu minus del mu lambda. Now you can see del mu a mu, that is fine, and I am just going to interchange that one, the position changing, del mu a mu del mu lambda minus del mu lambda. And as mu and nu are dummy indices, then we can definitely interchange this one, then it will be like del mu a mu minus del mu a mu plus del mu lambda minus del mu lambda. Now you can see del mu lambda lambda will be cancelled out. So what will left? It will left us del mu minus del mu, which is nothing but f mu nu. So we were starting about the expression f mu nu prime, you can see, and we are ending up with the f mu nu. So that means f mu nu prime is f mu nu. So this is the condition we are getting. So that means our f mu nu is gauge invariant. That means invariant under gauge transformation. So the first option, whatever it is given, that is correct, right? Now you can see, okay, fine. Now coming to the second one, f mu nu a mu a mu. If okay, sorry, f mu nu a mu a mu. Okay, f mu nu a mu a mu. Now you can write here del mu a mu minus del mu a mu and a mu a mu. Now if we have to calculate f mu nu okay, so we have to calculate f mu nu prime a mu prime a mu prime. Is this equal to f mu nu a mu or not? Okay, so we have to calculate this one. This one we have to calculate. So how to calculate this one? Just right now we have calculated, just now we have calculated f mu nu prime equals to f mu nu, right? By that expression by the option number A. So as we have already calculated f mu nu prime equals to f mu nu, so we don't need to calculate this one again. If you just see f mu prime a mu prime is equals to f mu a nu, then only we can tell that okay, as a whole this term is invariant under gauge transformation. Now coming to this term. This term is a mu prime. A mu prime is what? A mu plus del mu lambda. A mu prime is what? A mu plus del mu lambda. So if I just multiply that one, del mu a mu prime, then it is coming a mu plus del mu lambda into a mu plus del mu lambda. Now you can definitely check that so you can definitely check that condition, that a mu, okay, this is del mu lambda, a mu plus a mu del mu lambda plus del mu lambda into a mu plus del mu lambda del mu lambda. So I am just talking about these things, that a mu prime that is not equal to a mu, because there are so many terms which are not cancelled out. So that means if it is not correct, that means whatever our B option was there, that f mu, a nu, this will not be gauge invariant, because this one is not equals to f mu, a nu. Okay, so this is the case. So from our mathematics, the option number B is not correct. Now coming to option number C. Now you can see definitely that if option number A is correct, that means f mu is gauge, invariant under gauge transformation, then f mu, this product will also be invariant under gauge transformation. You can check by yourself also, but yeah, fine. So okay, now coming to D option, a mu. A mu. So now you have seen that a mu prime is this one. So I am just going to write here a mu. What will be the a mu? It will be prime. A mu plus del mu lambda. A mu plus del mu lambda. Now you can see a mu is fine, but there are some other terms also. A mu del mu lambda plus del mu lambda a mu plus del mu lambda del mu lambda. So these terms are not exactly 0, so that means it is not equals to a mu. So whatever in the option number 4 is there, a mu, it is not equals to a mu, which means that a mu is not invariant under gauge transformation. So coming to the question again, yes, in that question this is also not correct. So now which are the correct option for our case? It is like A and C. Okay, so if you people does not understand how C is coming as a gauge invariant, then I am just going to calculate it a little bit quickly. From here I can calculate. So here let me erase these things a little bit quickly. Okay, so what is this in the option number C? Option number C is f mu, right? So what we have to calculate? We have to calculate f mu prime. Now in that first question we have already calculated that f mu prime is f mu. This condition we have already satisfied and we have proved that one also. Now coming to the f mu prime condition. So what will be f mu prime? Del mu a mu prime minus del mu a mu prime. Now if I just write here del mu plus del lambda minus del mu a mu plus del mu lambda. So del mu a mu plus del mu lambda minus del mu a mu minus del mu lambda. So you can see definitely that it will come as del mu a mu minus del mu a mu, and these two will cancel out because these are the dummy indices. So we can write del mu lambda minus del mu lambda. So what is left here? It is like del f mu nu. So from these expressions we can have that f mu nu prime is equals to f mu nu. So this condition is satisfied. That means f mu nu is invariant under gauge transformation. You can see this was the question. Which one? I mean, which option will be invariant under the gauge transformation? A mu goes to a mu prime as a mu plus del mu lambda. Okay, and the correct answer are A and C. So now we have to move to the next question. If it is understandable by all of you, then we can go to the next question. Okay, so this is the next question. Given the components of the electromagnetic field tensor F0i equals to minus EI, the component of F02 tilde is what? So first of all I want to tell you what is this one and what is like electromagnetic field tensor at least. This is the dual electromagnetic field tensor. I mean, you can see there is a tilde just up of the F expression. So F mu nu, this is electromagnetic field tensor, and F mu nu tilde, this is dual electromagnetic field tensor. So what is the expression between F mu nu tilde and F mu nu? So F mu nu tilde is equals to half, I think half epsilon alpha beta gamma delta F mu nu. I will tell this one what is this one basically. So you can see there is a expression between this one and this one, right? And what is alpha epsilon alpha beta gamma delta? Alpha beta gamma delta, this is nothing but Levi-Civita tensor. I think sir already told these things, Levi-Civita symbol. So what is the speciality of this expression, this Levi-Civita symbol? Like epsilon alpha beta gamma delta, it will have three values. It will have 1, it will have -1, and it will have 0 value. When it will have 1 value, when alpha beta gamma delta, these will be like even permutation. I will tell you what is even permutation. Let me write here first. And -1 will be in which condition? Alpha beta gamma delta will be in odd permutation. And when it will be 0? Otherwise. Otherwise means in other all situation it will be 0. Now coming to even permutation and odd permutation. What is even and odd permutation? Let me write here alpha beta gamma delta as delta. Let me write it as like 0, 1, 2, 3. If it is like that, that is obviously even permutation. Now also I can write like 0, 1, 2, 3, right? So 3, 0, 1, 2. This is odd. Why it is odd? Because one permutation we have changed, one order we have changed. Now coming to again, let's say 2, 3, 0, 1. This is even. So like that, and otherwise it is 0. Why? When it will be 0, like let's say alpha beta gamma delta, if it is like let's say 0, 0, 1, 2, like these two will be equal, so obviously it will give a 0 value. 1, 1, 0, 2, that type of combination will also give a 0 value. So like that. So what is so now F mu nu tilde was half epsilon alpha beta gamma delta F mu nu. So with the help of this expression we can construct f mu nu tilde matrix, because we know that f mu nu matrix, right? So I am not going to explicitly calculate all the terms of that f mu nu tilde. I am just going to write the final expression of f mu nu tilde. I think sir already has explained these things very well. So this is the f mu nu tilde expression. It will be 0 minus bx minus by minus bz, then bx by bz 0 0 0, and it is like ex by c minus ey by c. This is minus ex by c, ey by c, ex by c minus ex by c. So this is nothing but a dual electronegative field tensor. Now in that question they were asking that 0 2, I think. Yes, 0 2. So what will be the component of f tilde 0 2? Now how we can read this one? This is nothing but 0th 1 2 3. Again from here also 0 1 2 3. So 0 0 term is 0, 0 1 term 0 1 term is minus bx, 0 2 term is minus by. Like that we have to calculate. So they are asking about f 0 2 tilde, so which is nothing but 0 2 element. So 0 means this is 0th row and 2 means 0 1 2. Now you can see it is nothing but minus by. So minus by, in that option they have written here like minus b1 minus b1 b1 b2 minus b2. So b1 b2 b3 is what? b1 b2 b3 is nothing but b1 is bx, okay, b2 is by, b3 is bz. So very similarly if I just calculate here, then what will be the answer? The answer will be minus b2, because it is minus by. So now coming to the option again, this one. So minus b2 is the correct one. So what will be the answer for that expression? The answer for that question will be D, minus b2. Okay, so I think we can go to the next question, or if you have any doubt you can ask me. Okay, so coming to the next question. Given f10 equals to f20 equals to 0, f30 equals to minus 4 in appropriate units, which of the following may represent the 4-vector potential? Where t represents time and z denotes the z component of position vector. I mean, in that option they have mentioned here z, and t was also mentioned in that options. So here a mu equals to 0 0 0 minus 4t, a mu equals to 2z 0 0 minus 2t, a mu is 0 0 4t, and a mu is minus 4z 0 0 0. So this is the question and answer. So in that question, okay, from the very first, from the previous question we can have one knowledge that f0i is minus ei, right? So we are going to use this expression here also. f0i equals to minus ei. It is already mentioned in the previous one. Now they have, in that question they have told that f10, f20, f03 is minus, f10, f20 is 0 and f03 is minus 4. You can see it is written as f03 is minus 4. We are just focusing on this one right now. f03 is minus 4 and f0i has a in general formula that f0i is minus ei. Now as in that question it is given that f03 is what is given here, -4. Okay, so -4, so that means we can definitely write minus E3 is -4. That means E3 is 4. So what is E3? I told you that it is E1 is like EX, E2 is like EY, and E3 is like EZ. So EZ is 4 basically, and from other two expressions we can have EX and EY are 0. That means E is nothing but 4Z cap. This is the expression. Okay, 4Z cap. So we get from that condition E vector is EZ cap. But what is the use of this conclusion in that question? You can see in that question they are asking about mu expression. Which one will be the mu expression, right? So now first of all I am just going to do one by one all of the expression options. You know E has a relation between A and phi, right? So we are just going to check that one, that which option will give this expression, and E means it is like 4, it is 4. Okay, so which option will give this type of expression? If let's say this one will give this one, then it will be correct one. If this one will give the expression E vector will be 4Z cap, then this one is correct. Like that we have to calculate. So now coming to the first option. First option is 0, 0, 0 minus 40. mu is 0, 0, 0 minus 40. Now what is the expression relation between E and A? It is like minus E equals to minus rad phi minus del A del T. You can see minus rad phi, these are all 0, so that means it is giving 0. Del A del T, it is like del T of minus 40. Now you can see del minus minus plus and del T of 40, it is nothing but 4. So our E mod value of E is giving us 4, and also from our expression also we are getting that this one. So mod value of E is what? It is nothing but 4. That means whatever given in the equation number A, that is correct. Now coming to the B one, 2Z 0, 0 minus 2T. 2Z 0, 0 minus 2T. This is mu. Now again we have to calculate E minus grad phi minus del A del T. Now you can see from here we can have a conclusion that minus 2 minus del T of minus 2T. Now what will happen here? Minus 2 minus minus plus del T of 2T, it is nothing but plus 2. So it is giving 0. Now the answer is like E is giving us 0. So the B option will not be the correct one. Okay. Now coming to C. C is 0, 0, 0, 40. 0, 0, 0, 40. It is mu. So again we are just going to write here minus del A del T minus grad phi. So del T of 40 minus 0. So what will be the answer? It will be like minus 4 del T, which is minus 4. But in from our conclusion we got equals to 4. So E is not minus 4. That means this option number C is also not correct. Now coming to fourth option, minus 4Z 0, 0, 0. A mu is minus 4z 0 0 0. So what is E here? E is minus grad phi minus del A del T. So minus of minus 4z minus del A del T, and this is 4z and this is 0. So you can see obviously E is giving us 4z. That is the correct one. So our option number D, whatever it is given here, that is correct. And as a conclusion, what type of how many options we are getting for that f03 equals to minus 4, f10, f20 equals to 0 condition? It is like A option and D option. These two will be the correct one, in which f10 equals to f20 equals to 0 and f03 equals to minus 4. And from that also we are getting that E is 4 into z cap, like that. Okay, so now we are just going to move on to the next question. Okay, so the next question, consider the 4-vector potential A mu. A mu is epsilon mu I q dot x, with epsilon mu equals to 1 by root 2 0 1 minus I 0, and q mu equals to root 2 E0 1 0 0 1. Define the electric field associated with this as EI equals to real of Fi0. That is, if Fi0 is complex, take only the real part as the components of the electric field. Which of the following is the correct expression for the electric field corresponding to the given vector potential? And they have already given that note q dot x equals to q mu x mu, and there are 4 options for that. Okay, so what is basically the question? This is the expression for 4-vector potential. Okay, and they have given epsilon mu value as well as q mu value. They told that our EI will be nothing but real form of Fi0. That means whatever the Fi0 will be, we are just going to take the real part of this for EI expression. Then what will be the expression for E? You know that E vector means this one, right? So I can write as like EI, then x, like alpha cap, and alpha is going from x, y, z, and I is going from 1, 2, 3. So we have to calculate the expression for E, and there are 4 options there. So this is the question, and they have mentioned this one. This is the very important thing, like q dot x equals to q mu x mu. So how to calculate this answer? How to do the answer of that question? First of all, I am just going to write this one, A mu expression. It is a little bit big in calculation, so we will take a little bit more time on that, so that all of you can understand. A mu is epsilon mu e to the power I q dot x, right? E to the power I q dot x. Now, they have mentioned in that question that q dot x is nothing but q mu x mu. Now you can see this is a 4 vector thing. So we can split it into like q0 x0 minus qi xi. So qi xi is what? Qi xi is nothing but q dot x. I have just mentioned here the vector form. Vector form means it is a 3 momentum calculation. 3 momentum condition. Okay. And okay, one more thing is that I just want to write here all the expressions. So epsilon mu is what? Epsilon mu is 1 by root 2, then 0 1 minus I 0 and q mu is what? Q mu is root 2 E0 then 1 0 0 1 1 0 0 1. So this is the expression for q mu. It will be very much helpful after a little bit calculation, and this is epsilon mu. Okay, so a mu is epsilon mu e to the power I q dot x. So how to write that q dot x? We can write it like e to the power I then q0 x0 minus q vector dot x vector. So x0 is what? x0 is nothing but t, then q0 t minus q vector x vector. So this is the thing. Now this is a mu. Now a0, what will be a0? a0 means epsilon 0 e to the power I q0 t minus q vector dot x vector. Now definitely, as epsilon mu has the form 1 by root 2 0 1 minus I 0, we can definitely say that epsilon 0 is 0, epsilon 3 is 0, right? Because you can see the first one and the fourth component, these two are 0. That means epsilon 0 is 0, epsilon 3 is 0. So as epsilon mu is in the multiplication form, then definitely we can say a0 and a3 are 0, right? Because epsilon 0 0, epsilon 3 is also 0, and if mu was epsilon mu e to the power I q0 t minus q this, right? So from that condition I can already write that a0 is 0. Now coming to the 1 2 3 condition, we already knew that a3 is 0, but we have to calculate a1 and a2, right? So in general, if I write ai, then ai will be what? Epsilon I e to the power I q0 t minus q vector dot x vector. Don't confuse about this I and this I. This I is for 1 2 3 and this I is nothing but the complex number. Here I is root over minus 1. This I is this I, but it is for I will be 1 2 3. Okay, or we can write j also to remove the confusion and all. So this is the expression for 3. Let me write here g so that it will be non-transparent. So this is the case. Now they are asking about e, they are not asking about j, right? So what will be the e from the a expression? We know that this one fi0 is what? Okay, why I am writing here fi0? Because in that question you can see ei is nothing but real of fi0. So if anyhow I can have the expression for fi0, then the real part of that fi0 will be ei. So fi0 is what? Del mu a0 del 0 ai, sorry, del I a0 minus del 0 ai, right? So here we have written the ai expression. Ai means aj I have written here. So del I a0 minus del 0 ai. So as a0 is 0, so that means we don't want to do anything with that. Then what will be happening here? Del 0 ai only. So fi0 is nothing but del 0 ai, and del 0 is what? Del t of ai. And what is ai? Del t of ai. Ai expression I have already mentioned, epsilon I then e to the power I, okay, e to the power I q 0t minus q vector dot x vector. So if I do a simple mathematics, like there will be a derivative with respect to t, then it will be like minus epsilon I, then after doing the derivation, what will be the answer? E to the power I q0t minus q dot x. Now you can see it is the like e to the power x form, then I q0 will come out. So minus I q0 epsilon I e to the power I q0t minus q vector dot x vector. This is the thing. Now as we got fi0 expression, fi0 is what? Fi0 is minus del 0 ai, and this is minus q0 I e to the power I this, and then epsilon I. So we got this expression. So now what we will do? We will calculate EI. EI is real of fi0. So first of all, E1, let's say this is 1, okay, E1, real of f10. So f10 will be what? Minus I q0 epsilon 1 e to the power I q0t q dot x. Now we need these expressions, whatever it was given there, this one and this one. Okay, so from that epsilon 1 is what? 1 by root 2. q0 is what? E0 into root 2. So epsilon 1 by root 2, q0 E0 into root 2. Now I am just putting these values here. Minus I root 2 E0, epsilon 1 was 1 by root 2, and this one. So this one is what? Okay, q dot x. So it will be like cos qx plus I sin qx. Okay, so what will be the answer here? It will be like root 2 is cancelling out, minus I E0 cos qx plus I sin qx. Now you can see, if I just do a little bit calculation, then it will be minus I E0 cos qx, minus minus it will come as plus sin qx into E0, and as E1 is real of f10, you can see the real part is nothing but E0 sin qx. So E0 sin q and x. Oh, sorry, sin q. Okay. Sin qx. Sorry, sin qx. So this is the expression for E1. Now we have to calculate E2, and E3 we know that it is 0 because A3 is 0. This one, A3 is giving 0. Then we can obviously tell that E3 is 0. So we don't need to calculate E3, we just need to calculate E2. So what will be E2 here? I am just going to remove the one part, or I can write any other place also. Yes, I can write here also. So E2, how to write? E2 will be like real of f20. So f2 was what? Let's say real of minus E0. If I just put these values, I am not going to calculate these things again. So it will be like cos qx plus I sin qx. You can check by yourself also. Then it will be like real of minus E0 cos qx minus I E0 sine qx. So as they are asking about real value, then it will be like only minus E0 cos qx. So E1 we got as U0 sine qx, and E2 we got as minus E0 cos qx, and E3 is 0. So what will be the value of E vector? E vector is nothing but E1 x cap plus E2 y cap plus E3 z cap. So if I write like that, then it will be x cap minus E0, E0 is missing here, E0 cos qx y cap. So E0 into sine qx minus cos qx x cap, this is y cap. That will be the answer. Now we have to come to the option, which one is the correct option for that. E0 sine qx x cap minus cos qx y cap, whatever right now we told. So this one is the correct one, and other things will not be the correct one, because we got this answer, sine qx into x cap minus cos qx into x y cap. Okay, so this is a little bit a tricky question, but I think you understand that one. So we are moving to the next question. Okay, this is a very simple question. Question number 7. Consider a reaction E minus E plus going to mu plus P mu minus mu plus, in which an electron and positron annihilate each other and a mu1 and anti-mu1 are created. Let the four momenta of these particles indicated by the subscripts are Pe minus, Pe plus, P mu minus, P mu plus. Which of the following delta functions correctly indicate the energy momentum conservation in the reaction? And there are four options. Okay. So E minus E plus going to mu minus mu plus. So if I write a Feynman diagram, I think you all know that what is Feynman diagram, but no, like I'm not going to write the exact Feynman diagram, but let's say I'm just writing like that, E minus E plus mu minus mu plus. So whatever will be there, the momentum is like Pe minus Pe plus P mu minus P mu plus. As a momentum conservation law, what will be the momentum relation between these four particles? The total momentum should be conserved, right? That means our initial momentum will be equal to our final momentum. So what was the initial momentum? Initial momentum was Pe plus plus Pe minus. And what is final momentum? Final momentum is P mu minus plus P mu plus. So this is P initial and this is P final. So according to according to momentum conservation, Pi should be equals to Pf, right? So that means Pe plus plus Pe minus should be equals to P mu plus plus P mu minus. Now they are asking about the correct delta function. So what is the nature of the delta function? Let's say I am writing here x minus x0. That will be 1 if and only if x will be x0. That will be 0 if x is not equals to x0. Okay. So now you can see from that expression I can write one thing, that Pe plus plus Pe minus minus P mu plus plus P mu minus is 0, right? So if I write delta function is like Pe plus plus Pe minus minus P mu plus minus P mu minus, that will give a energy momentum conservation for the reaction e plus e minus going to mu plus mu minus. Okay, now also there is one thing, it is like this one. So whatever we have written there, that e plus e minus minus mu plus minus mu minus, so I can also written as like mu plus mu minus minus pe plus minus pe minus. Now you can see this is the correct option for the expression e plus going to e minus, e plus e minus going to mu plus mu minus. So now we have to see which option will be the correct one, mu plus mu minus, e plus e minus. Okay, see here, mu plus mu minus minus e plus e minus, that one is the correct one because it can be written as like plus minus of this one. So this is nothing but p final, and this is nothing but p initial. So p final minus p initial of delta 4, and it will be equal to 1 when these two will equal to, the final will be equal to initial one. So this is the exact answer. Like the delta function means this one, that delta of x minus x0 will be 1 if x will be x0, and it will be 0 if x is not equals to x0. So by that condition also we can see for the energy momentum conservation in that reaction, the option B will be the correct one. Otherwise you can see any other option that will not give Pi equals to Pf condition. Okay, so that's why it is like that. Okay, so I hope it's understandable. Now we can go to the next question. Which of the following is or are the correct answer? So this is about the gamma function. There are 4 types of gamma function: gamma 0, gamma 1, gamma 2, gamma 3. Basically there are some rules of these gamma functions. I think Sarah has already mentioned these things very clearly. So gamma 1, gamma 2, gamma 3, gamma 0, these all are anti-commutative. Anti-commutative means what? Like gamma 0, gamma 1 plus, it will be 0. Plus means what? Gamma 0, gamma 1 plus gamma 1, gamma 0 will be 0. So gamma 0, gamma 1 should be minus gamma 1, gamma 0. So this is not for 0, 1 combination, this is for all other combinations also. Let's say gamma 0, gamma 2 plus, this is also 0. Gamma 0, gamma 3 plus, this is also 0. Similarly, gamma 2, gamma 3 plus, this is 0. Gamma 1, gamma 3, 0, and then any other combination is there, 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6. Okay, any other one more is there, gamma 1, 2. Okay, 1, 2 I did not write here. So gamma 1, gamma 2 plus, that is also 0. So these all gamma functions are anti-commutative to each other. Now coming to the option whatever given here, you can see here gamma 0, gamma 1 is gamma 1, gamma 0. That means gamma 0, gamma 1 minus gamma 1, gamma 0 is 0. Gamma 0, gamma 1, commutator is 0. From that expression we can conclude that commutator is 0. But I told you that anti-commutation will be 0. That means that option A will not be correct. Now coming to the option B. In that option B, gamma 0, gamma 1 will be minus gamma 1, gamma 0. So gamma 0, gamma 1 is minus gamma 1, gamma 0. That means what? Gamma 0, gamma 1 plus this one is 0. So which is gamma 0, gamma 1 anti-commutation, right? So this one what I told right now. So the B option is correct one. Now again you can go to the C and D options. It will not be the correct one because gamma 0 gamma 1 will be minus gamma 1 gamma 0. No 2 will be there in front of this one, and plus means plus will also not be there, minus will be there. So the correct answer is B. The main thing here is that like gammas are anti-commutative in nature, gamma functions. Okay. So coming to the next question, which of the following is or are correct? This is also about the gamma function. So we have to calculate which option will be the correct. So let us calculate one by one. First one, gamma 0 gamma 1 gamma 0 dagger, gamma 0 gamma 1 gamma 0 dagger. Is it gamma 1 gamma 0 dagger? Okay, yes. So A B dagger, what is the expression for that? B dagger A dagger. So if I write like that, then it will be gamma 0 dagger gamma 1 dagger. Now by the properties of gamma functions, gamma 0 dagger is gamma 0, gamma I dagger, I means 1 2 3, that is minus gamma I. So here gamma 0 and gamma 0 dagger is gamma 0, gamma 1 dagger is minus gamma 1, and also by the property of gamma 0 square is 1. So you can see here it is gamma 0 square minus gamma 1. So the answer will be gamma 0 square is 1 and minus gamma 1. Now see the option here. Gamma 0 gamma 1 gamma 0 whole dagger will be minus gamma 1. That means it is the correct one. Now coming to the fourth option, you can definitely see that the fourth option and the first option is a little bit complementary to each other. Like if it is minus gamma 1, it is gamma 1. So that will not be possible because we have already calculated it will be minus gamma 1. Okay. Now coming to the B option. B option is gamma 0 gamma 1 gamma 0 dagger. Whatever we have just calculated, it will be minus gamma 1. Is it equals to this one or this one? You can see the expressions are okay. So it has gone. Okay, fine. So we were in that expression, right? So I told you that like there are some properties of gamma functions. That means gamma 0.
Ma'am, you are muted.
Oh. Okay, can you hear me? Yeah. So like I told you that like gamma 0, gamma 1, gamma 2, gamma 3, these three has some properties. Like what is the properties? Okay, so what are the properties for this gamma functions? It is like gamma 1, like let's say gamma, any type of gamma. So gamma 1, gamma 2, the anti-commutation will be 0. Any type of combination will be, any type of two gamma functions anti-commutation will be 0. And for especially gamma 0 dagger is nothing but gamma 0, gamma I dagger is minus gamma I. What is I? I stands for 1, 2, 3. And another one property for gamma 0 is gamma 0 square is 1. So these three property we will use for our question. So the first option is gamma 0, gamma 1, gamma 0 whole dagger. Gamma 0, gamma 1, gamma 0 whole dagger. Now you can see that one more properties I am going to use. AB dagger is B dagger, A dagger. So if I write here gamma 0 dagger, gamma 1 dagger. And also I told that gamma 0 dagger means it is nothing but gamma 0. And gamma 1 dagger is minus gamma 1, because you can see from this gamma I dagger is minus gamma I. So gamma 1 dagger will be minus gamma 1. So gamma 0 whole square into minus gamma 1, and gamma 0 square is 1 into minus gamma 1. Now you can see it is nothing but minus gamma 1. So from that question we can conclude that gamma 0, gamma 1, gamma 0 whole dagger is minus gamma 1. That is correct. And also you can see very carefully that in a left hand side all the expressions are same for all the options. Right hand side is different. So for right hand side, as we have already proved that it is minus gamma 1, so obviously it should not be plus gamma 1. That is obviously done. Now we have to calculate among these two which one will be the correct one, because you can see minus and plus is there and the other expressions are same. So now just only we have to take one condition, then another one will automatically come out. Gamma 0, gamma, what was that? Gamma 1, gamma 0 dagger. So gamma 0 dagger, gamma 1 dagger, gamma 0, gamma 1 dagger. Now you can see if I write here gamma 1 dagger minus gamma 1, right? And I told you that gamma 0, gamma 1 are anti-commutator. That means gamma 0, gamma 1 will be minus gamma 1, gamma 0. So minus gamma 0, if I write this one gamma 0, gamma 1 in a little bit exchange position, then it will be minus gamma 1, gamma 0. Then you can see it is like gamma 0, gamma 1, gamma 0, right? So it will be plus gamma 0, gamma 1, gamma 0. And again also minus gamma 0, gamma 1, and then minus gamma 1. So gamma 0, gamma 1, gamma 0 whole dagger, it is nothing but minus gamma 1, as well as we can write it like gamma 0, gamma 1, gamma 0. Okay. So from that first option we have already found that minus gamma 1 will be the correct one. And the second option will be gamma 0, gamma 1, gamma 0. Now let us come into here. Gamma 0, gamma 1, gamma 0. That means C option. So A option will be the correct one, C option will be the correct one. Okay. So this is the case. Now coming to the last question of our session, today's session. Yeah. So this is the question. The force momentum of a particle is P mu. P mu is E0, 0, P, where E is its energy and P is the magnitude of three-dimensional linear momentum. The mass of the particle is m. If psi is the wave function representing this particle, which of the following represents to the Dirac equation satisfied by psi? Okay. And there are four options. So in that question they have mentioned as P mu E0, 0, P, and they have taken that mass of the particle is m. So what will be the correct Dirac equation for psi? So then I am just going to write here E0, 0, P, and mass is m. So what is the Dirac equation in general? The Dirac equation will be for four momentum case, okay, it will be like gamma mu P mu minus m psi equals to 0. Now gamma 0 p0 minus gamma I pi minus m psi equals to 0. As p mu is given E0 0 p, that means we can definitely tell p0 is E, p1 0, p2 0, p3 p, right? So gamma 0 p0 minus gamma I pi minus m psi equals to 0, which will give gamma 0 E minus gamma 3 p3 minus m psi is 0, which is nothing but E gamma 0 minus p gamma 3 minus m psi equals to 0. Gamma 0 E minus gamma 3 p minus m psi equals to 0. This is the required Dirac equation. So now we are going to see the option gamma 0 E minus gamma minus gamma 3 p minus m psi. So that means the option will be B. Okay, this is a very simple question. So this is up to today's session. There were 10 questions. I am going to show these things fully so that you can, if you have any doubt, you can ask me. Actually or whatever we have written here, that was already deleted because of the hang of that laptop. So no problem. If you have any question, you can ask me. I will answer that. So this is the first question. Okay, and the option is, I am just going to write here the correct option also. This is the correct option. Now question number 2. This one is question number 2. Here also the correct option will be this one. Just right now we calculated, so that's why we have already remembered that one. Okay, now question number 3 is this one. In question number 3, the options are, this one is correct one, this one is correct one. Okay, now this one, for this case, I think this one was correct one.
Ma'am, can you please repeat this question?
Which question?
Ma'am, this question.
This one.
The one with the question. Yes, ma'am.
Okay. So electromagnetic field potential. Okay, given the components of the electromagnetic field potential F0i equals to minus EI, the component F0 tilde is what? So what is F0 tilde? F mu nu tilde. F mu nu tilde is nothing but dual electromagnetic field tensor. Okay, so F mu nu tilde. So it has a relation with F mu nu. What is the relation between these two? It is like 1 by 2 alpha beta gamma delta F mu nu, where alpha beta gamma delta is Levi-Civita symbol. And I think you all know that what is the property of this, like it is minus 1, plus 1 and a 0 value when alpha, beta, gamma, delta will be in even permutation, and these things will be in odd permutation, and otherwise it will give the value of 0. Okay, so now we know that what is the expression for F mu nu matrix. There is a 4 by 4 matrix. Now just put the expression here, then we can get epsilon alpha beta gamma delta F mu nu. So we can get the matrix for that F mu nu tilde, right? And it will be also 4 by 4 matrix. So I did not explicitly calculate that f mu nu each and every component f mu nu tilde. You can see that f mu nu tilde means what? f00, f01, f02, like that there will be 16 terms. So you can definitely calculate that one, but I just wrote it down from the book, and after that I told you. But yeah, with the help of this expression you can write definitely what will be the each and every component for f mu nu tilde. So if I write the matrix here, then it will be like 0 minus bx minus by minus bz, bx, by, bz, then this is 0, this is ez by c minus ey by c, this is 0, this is 0, this is ey by c, this is ez by c minus ez by c, and this is ey by c, and it is ex by c, this is minus ex by c. So this is the expression for f mu nu tilde. Now in that question they are asking that f0 tilde. So how to calculate this one? F mu nu is nothing but it is f mu nu tilde. If I tell, it is like 0 1 2 3 0 1 2 3. So 0th 0th is this one, 0 1 means this one, right? So similarly they are asking about f02. So f02 means 0th row and third column, 0 1 2 third column. So this one they are going to ask. So what is this one? This one is nothing but minus by, you can see. So it is minus by. Now from that options in option they are asking, they are given that b1 b2 b3 something like that. So what will be the minus by case? b1 is bx, b2 is by, b3 is bz. So if I write here minus by, then it will be minus b2. Okay, so just going to the option, you can see minus b2 is the answer, which is option number D. So do you understand that one? Like you have to just write the f mu nu tilde expression, if mu nu tilde matrix form, and after that you can get the component f02 tilde, and you can see that it will be minus by. So we can write here minus b2. Okay.
Yes, ma'am.
Okay, so this is the fifth question. And I think the answer was this one and this one. Yes, maybe. Okay, now coming to the next one. Yes, next one is a little bit tricky, and from the next one we got the answer as E. Okay, now in the next question, this one is the next question. There you can see the answer will be B. Now in the next question, yes, this is the next question, the answer will be B again. And in that next question, where is the next question? Okay, oh, it is already there, A and C. And coming to the last question, for that last question also the answer will be B. So these are the questions. It was taken from the previous year assignment 9 question paper. So yeah, if you have any doubt you can ask me, or otherwise we can go for the next week. Next week there will be 10th assignment. Okay, so if you don't have any thing to ask, to comment, then we can stop today's session and we will meet tomorrow. Sorry, next week. Okay. Okay, so just check once. I think there will be no problem. If you have any question also, you can ask me in the next week also. If there is any problem in this week question paper, then you can ask me in the next week, so that we can discuss these things also in the next week. Okay. There is something. Oh, okay. Okay, so if there is nothing, then we can stop today's session and we will meet tomorrow. Right? Not tomorrow, next week. I'm talking about tomorrow each and every time. Okay, so okay, bye bye.
Bye, ma'am. Bye, ma'am. Thank you, ma'am.